Hello dear students, after a short break we will discuss second law of Mendel, that is law of segregation. Let's take that format. Already we discussed law of segregation. First we will have to write parent, these are parent, then we have formation of gametes. So whenever we have the formation of gametes, you know that one diploid condition is converting into haploid condition. Already we discussed. And then after we have the random fusion, that is fertilization. So whenever we have the random fusion, we have 4 heterozygous plants. We are showing one here to make it simple. So this one is F1 generation. F1 generation. We discussed in F1 generation Mendel got hybrid, but there is no change in phenotype despite of having change in genotype. So Mendel was very curious. I already taught you, he was damn curious scientist. He thought what will happen after F1 generation, and that thinking of Mendel led to the foundation of the law of segregation. So already we discussed about pea plants. They are naturally self-pollinated plants. They can do self-pollination. So Mendel did selfing. Selfing. This is the word for self-pollination. And what he did, he let F1 generation to be self-pollinated simply because pea plants are having this natural tendency to be self-pollinated. So whenever we have the selfing, try to understand here, this could be the parent, this is, we have now parent for F2 generation, and then after we will have the formation of gametes. There is a formation of gametes, see here, and we will have random fusion, that is fertilization, and Mendel received F2 generation. So we will discuss this step here. To make it simple, we have to draw Punnett square. So when we draw Punnett square, we get results easily. One parent we have to show here, and one parent we have to show this side. So you have to match this one capital T, this one capital T, capital T, small t, and small t, small t. So that is F2 generation. This one is F2 generation. So what Mendel received in F2 generation? Let's see. This one is homozygous dominant, capital T, heterozygous, capital T, small t, this is also heterozygous, and this is homozygous recessive. That is the result. So simply when we understand, try to understand all my dear students, it will be tall due to both the dominant factors. It will be also tall because there is a presence of the dominant factor, law of dominance will apply. It will also tall, again law of dominance will apply. And here we have the absence of dominant factor. I placed one example, that Hrithik Roshan and Tushar Kapoor. So here absence of Hrithik Roshan, here is also Hrithik Roshan, here is also. So other actors cannot express well, but in the absence of dominant actors, recessive actors can express. So this is the condition Mendel received. So when we write the result, see that result, how many tall? It means phenotypic ratio is 3:1. And when we write about genotypic ratio, phenotypic ratio discussed already, that is external appearance. We also call physical appearance. So that is phenotypic ratio. When we have genotypic ratio, that is, this condition is only 1 here. This condition we have 2 heterozygous, and this condition is only 1. So that is genotypic ratio. That is the result Mendel got after the selfing in F2 generation. And then he gave his second law, law of segregation. Try to focus here. I want you to focus here. You can see we have the blending of characters, dominant factor and recessive factor. But what is happening at the time of gamete formation, when it is becoming parent, at the time of gamete formation, factors are able to segregate. You can see, and they are able to restore the diploid condition. So that is law of segregation. So this law states that allelic factors can separate at the time of the formation of gametes, and they can be unite and restored diploid condition again. You will have to focus in this law, that is phenotypic ratio along with genotypic ratio. These two terms I taught you earlier. I hope you have understood. It is quite simple when you know all the terminology of genetics. Then after law of segregation, because law of dominance and law of segregation based on monohybrid cross, Mendel wanted to know about dihybrid. When we have the fusion of two characters, students, please try to understand, when we talk about characters and factors, these are the two different terms. Hybrid, it means we have the fusion of two different factors or alleles. But when we talk about characters, it is different from factors. So Mendel wanted to know about what will be the pattern of the transmissions of the characteristics whenever we have dihybrid cross. It means when we have the fusion of two characters, what will be genotypic as well as phenotypic ratio. And for that he gave his third law, that is law of independent assortment. So we will have discussion of the third law, law of independent assortment. You will have only in your syllabus phenotypic ratio, but to get phenotypic ratio we have to understand how many genotypes are formed, how gametes are formed, and which kind of parents are involving, what is the characteristics of dihybrid cross as well. So law of independent assortment, this is the third law of Mendel, law of independent assortment. You need to clear-cut understanding. Law of independent assortment based on dihybrid cross. Dihybrid I already explained you must have known. But Let me brief you. Di means two. Two. It means whenever we have the formation of hybrids with two characters, that kind of cross is known as dihybrid cross. I hope you must have understood this one. A simple logic. Dihybrid cross is the cross when we have involvement of two characteristics. Let's take the parents one, and parents, because we are talking about two characteristics, so Mendel take shape as well as color. Two characters. First one is shape and color. And we discussed about alleles. Alleles are the alternate form of genes. It means there is a dominant and their contrasting counterparts are also there, that is recessive. So take that one. For the shape, that is round, and for the color, that is yellow. Yellow is dominant. Remember that table at the beginning of this chapter. I explained you that table, that is contrasting trait. So the round is dominant. You should go through that table again and again and try to understand which is dominant and which is recessive. And yellow is also dominant for color. And what is the counter of this one? We have to write a small letter, wrinkled and green. These are the parents. Two characters, shape and color. So round and yellow, wrinkled and green. Homozygous dominant for shape as well as color. Homozygous recessive for shape as well as color. Now you have to write here to make it simple, round and yellow, and this could be wrinkled and green. Now this one is, now we will have, these are the parents, and then we have formation of gametes. So my dear students, formation of gametes, again diploid condition is converting into haploid. So we have, there is a one R and one Y gamete of this, and gamete of this, there is a small r, could be gamete. And after the formation of gametes, what is happening? Very simple, you know that, fertilization. Very good. So whenever we have the fertilization, we have the mixing of characteristics. This could be F1 generation. This one is F1 generation. So what Mendel received in F1 generation? Two characters were present, and we had formation of gametes, Mendel observed, and then after you can see that one pure is converting into hybrid. So my dear students, try to focus here. It is very important point to understand. See here. Here is that one dominant for the shape is present along with recessive. Okay. Dominant for color is present along with their recessive. So in case of the dihybrid cross in F1 generation, Mendel got the same result. There is no change in phenotype despite of having change in genotype. It means we had a formation of hybrids, but phenotype remained same. That was the result Mendel got after the mixing of the two characteristics together. So he let this F1 generation to be self-pollinated to get the results in F2 generation, because he wanted to know what will be the pattern of separation of characteristics in F2 generation. So that idea creates selfing. We have selfing, that is self-pollination. Natural tendency of pea plants to be self-pollinated. So what Mendel did, he let F1 generation to be self-pollinated, and then after he received a result, he was very happy, he was astonished, and he gave his third law, that was law of independent assortment. We will discuss about this law in detailing. So this is F1 generation. After the selfing, Mendel received F2 generation. We will take again, for the F2 generation we have to make parents. For F2 generation we have to make parents. So see that one. What was the F1 generation? We have this one. Okay. These are becoming parents. Parents. And my dear students, quite technical this one is. To form the gamete from these two parents, I will give you the simplest method what I received from my teachers, Dr. Rupen Singh. So thank you to give me a simplest way of representation. He told me, Vipin, I am teaching you, when you get chance to tell others, try to spread this method of formation of gametes. It is a very simple method. We will discuss. It is a very advanced method. When you go in competitive exam, you will have such kind of questions regarding how to form gametes. See here, we have one formula to get how many gametes are formed. How many gametes are formed? We have one formula. Try to understand. 2 power n. Here n is number of heterozygotes. Number of heterozygotes. See here, we have 2 heterozygotes. It means we have power 2. Simple? Very simple. Thank you for giving me this concept. Thank you to my teacher. So we have 4 kinds of gametes. It is clear now. Now, what is the pattern of the formation of gametes? Conventional method. First, we understand, many teachers explain this method, that cross of this one with this one, then this one with this one, then after this one with this one, then after this one with this one. Let me simplify. Take one factor and cross with this one. Easy? Then after take another, this one, and then you have to combine. Like this. So what we got? We received 4 kinds of gametes. See here I gave you formula. 4 kinds of gametes are formed by applying this formula 2 power n. And then we have this method of the formation of gametes to simplify how gametes are formed. So this is very advanced method, my dear students, and this method we know fork line method. Fork line method. When you start studying about medical entrance, you will get this method. And for the higher studies, when you go, you will get this method. So this is very unique and very simple method I got from my teacher, Dr. Rupen Singh. So I would like to thank again and again, because it is a very technical. Then we have, see, this is the same. Here is also. So we have 4 kinds of same. You can see. That's one. So what we will have to do? Now we will have to place into Puneet square. So make Puneet square, because we have 4 factors here. See that one. 1, 2, 3. 1, 2, 3, 4. And 4 in this way. 1, 2, 3. So how many? 4, 4, 4, 4. We have the 16. You have to place simply. Don't be confused in capital and small letter, because it is very important. Two characters are together. My dear students, try to focus. See here. Now we have to match capital R, capital R, capital Y, then we have this one, then we have, able to understand? Capital Y, capital Y, capital R, then we have like this. Are you getting, everyone? Easy. You have to match only. Dominant factor we write first. Then we have this way. Okay? Match here. This one is okay, and this one is again. Match this, again match this, again. This is F2 generation. This one is F2 generation. Now we had that F1, when we received F1 generation, what was the condition? That one is the condition. Remember? That one is the condition. And small r, that one is the condition. Got it? So whenever we have this one, it could be round and yellow. When we have this one, it could be wrinkled and green. And whenever we have this condition, It is again round and yellow. So we have to find the genotype and then we'll get phenotype. Easy, very simple. Genotype will give the idea about phenotype. See here, both the dominant factor is there. Both the dominant factor is there. Both the dominant factor, 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 both dominant factor, both dominant factor. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. It means 9. 9 we have round and yellow. Homozygous as well as heterozygous conditions. Whenever we have both the dominant factors are present, we will have genotype round and yellow. How many? 9. And then we have next condition. You can see now this one. Capital R and small y. It means round and small y is for green. That y is representing about color. So this one is round and green. We have 2 RG, round and green. This one is round and green. See that one? Both the factors of color is small and we have the dominant one, so round will appear. And then see this one, round and green. So we have 3, round and green. Now come to the next situation. Here we have, that one is wrinkled and yellow. Wrinkled and yellow. Wrinkled and yellow. 3 we have wrinkled and yellow. And then the last one is both the factors are recessive. So we had this condition. And what is this condition? Wrinkled and green, that is 1. So this is phenotypic ratio, my dear students. Phenotypic ratio, what Mendel got, what we have understood, that is 9:3:3:1. We had parents, but we got 2 new combinations. What was the new combinations? We have this one, round and green, round and green, round and green, wrinkled and yellow, wrinkled and yellow, wrinkled and yellow. And when Mendel received results of F2 generation, he stated his third law of independent assortment. So very simple. I will give you understanding of this one, law of independent assortment. You know the meaning. Independent means free, assortment means free to combine, free to join, that is assortment. So what Mendel gave, I will explain simply. You can write according to the concept, whatever language you are using, but the concept should be there. Whenever, according to law of independent assortment, whenever we have the mixing of 2 characters, remember I am focusing about this word, 2 characters. Characters are able to separate and able to assort in successive generation. It means characters are able to separate. You can see independent assortment. We have the separation of the characters, and then we have the fertilization. And fertilization, it means we have the mixing of the characters, that is assortments. What Mendel told us, whenever we have mixing of two characters, characters are able to separate and are able to assort. They are free to be assorted. My dear students, this is the concept. Don't be confused with law of segregation. Law of segregation told about the factors, and law of independent assortment is telling about the characters. Both these terms are different, my dear students. I hope you have understood. We have the finishing of this topic, Mendel's law. The next video will discuss about few another important topics of genetics. Good luck. Try to understand. We'll meet again. Thank you very much.